Hi, we're going to start working on quadratics, and we're going to begin by graphing them by hand. We have to consider, what does the graph of a quadratic look like? We know that it's a parabola. We've talked about it before when we were looking at functions. Where do I locate coefficients A, B, and C? They're always in the same place on the quadratic. You just have to know what to look for. How do I find the y-intercept, the axis of symmetry, and then the vertex? Once we identify these are the first 6 slides, then there's another video where I pull all the pieces together and we actually use them to sketch a graph. All right, so let's get started. The parabola is a U. All right. Make sure it's a U and not a V, especially when they get really narrow. Don't make it a V. Parabolas look like this. Okay, they look like U's. They can go upside down. All of ours will go either up or down, depending on the sign of A. And it could go like this. Okay. All right, a quadratic function, it has to have an x squared. A quadratic must have an x squared term. If it doesn't, then none of this pertains. You have to have an x squared term. The coefficient in front of the x squared term is a. So a is the coefficient of the quadratic term, or the x squared term. B is the coefficient in front of the linear term, or the x raised to the first power. And C is the constant. So let's take a few minutes and let's identify A, B, and C in each of these quadratic equations. Now this underscore right here, that is not a typo. I put it there because a lot of students forget that if there isn't a number in front of a term, then it's assumed to be 1. So that's a 1. Do I have an x term? No, so that means my coefficient has to be 0. Do I have a constant? No, that means my constant has to be 0. Okay, I'm going to do number 2 with you. A is -1. B is -4. C, notice how I picked up that sign. Super important. And C is +2. I want you to hit pause. I want you to figure out A, B, and C for 3 and 4, answer the video questions, and come back. All right, here we go. A is 1/2. B is 0. Notice I don't have an x term. And C is -6. On 4, A is -6. B is +3. And C is 0. Okay, hope you did well on that. If not, rewatch it. Try it again. The y-intercept is a super important point because number 1 is easy to find. Easy to find. Easy. We like easy. And because of the symmetry of a parabola, if you find the y-intercept, then you know the point directly across from it on the other side of the axis of symmetry. And we'll get to that in just a second. All right, so I've included the information that we already found. We already found A, B, and C for each of these. Now we're going to find the y-intercept. It's super easy. It's just 0, C. So in this case, it's 0, 0. Number 2, it's 0, 2. Go ahead and hit pause and do 3 and 4, answer the video questions, and come back and check your work. All right, 3 is 0, -6, and 4 is 0, 0. All right, the next piece of information that's super important is called the axis of symmetry. It is the vertical line that divides the parabola in half. That means it creates a mirror image of each other, okay? I always abbreviate it AOS because axis of symmetry is so long to write out. AOS, axis of symmetry. This is the line that the vertex lies on, okay? And it also, so because of that, it's also the x-coordinate of the vertex, okay? So by finding this piece of information using this formula, I get two pieces of information. I get what is the vertical line and what is the x-coordinate of that vertex, okay? So we're going to do that for these four problems. Here we go. All right, so the axis of symmetry, let me change my color. The axis of symmetry, which is also the x-coordinate of my vertex, is equal to negative b over 2a. I want you to write that out every time until it just becomes burned into your brain, is 0 over 2, which is 0. So that means the axis of symmetry is the line x equals 0, and it is also the x-coordinate of my vertex. On number 2, the axis of symmetry, which is also the x-coordinate of my vertex, is equal to negative b over 2a. I take the opposite of b, that's positive 4, over 2 times negative 1, and I get negative 2. That means that the axis of symmetry is the line x equals negative 2, which is also the x-coordinate of my vertex. Go ahead and hit pause. Find the axis of symmetry and the x-coordinate of the vertex for 3 and 4 and come back and check your work. All right, here we go. The axis of symmetry, which is also the x-coordinate of my vertex, is equal to negative b over 2a, which is 0 over 1, which is 0. So this is the line x equals 0, and it is the coordinate x equals 0. Number 4, the axis of symmetry, which is also the x-coordinate of my vertex, is negative b over 2a, which is negative 3 over negative 2 times negative 6, gives me 3 over 12, which is 1/4. Okay? Hope you did well on those. All right, the next characteristic we're going to find is the vertex. We already have half of the vertex. We found it when we found the axis of symmetry. We know this number right here. Once we know that number, all we do is plug it into the equation and do the order of operations to evaluate. So we just plug in whatever we get for here, we plug in to our equation, being careful of negative signs when we square them, right? Here we go. All right, so the y-coordinate of my vertex is going to be 0 squared, which is 0. So that means my vertex is 0, 0. On number 2, the y-coordinate of my vertex is equal to the opposite of negative 2 squared minus 4 times negative 2 plus 2. This is equal to negative 4 because negative 2 squared is positive 4, and then this negative keeps it negative. The negative out in front stays. Plus 8 plus 2. When you add that together, you get 6. So my vertex is, sorry, that looks bad. It looks crumbly. My vertex is negative 2, 6. Okay, I want you to try 3 and 4 on your own. So hit pause, then answer the video questions, and come back and check your work. All right, here we go. I'm going to move over here. The y-coordinate of my vertex is equal to 1/2 times 0 squared minus 6. So that gives me negative 6. So my vertex is 0, negative 6. So here my vertex is the same as my y-intercept. Sometimes that happens, and that's okay. Here, I'm going to plug in 1/4, and I get -6 times 1/4 squared plus 3 times 1/4. So this is -6 over 16 plus, this is 3/4, so that's 12 over 16. So that's 6 over 16. So that is 3/8. So my vertex is 1/4 3/8. All right, this is the last slide before we go to the next video. The domain, this is nice because it's always. This is always negative infinity to positive infinity. This is an interval notation. The range depends on two things: the y coordinate of the vertex and the direction of the graph. So does it open up or down? Does it open up or down? That's what I mean by the direction. Does it open up or down? So when the graph opens up, the range is the smallest y value, because you're going to have a minimum, the smallest y value to positive infinity. So let's try it for this one right here. Here's my x coordinate of my vertex. Here's the y coordinate of my vertex. This opens up, so my range is from -6 to positive infinity. When the graph opens down, or there's a negative in front of, when the graph opens down, or there's a negative in front of A, then the y coordinate of my vertex, that's going to be the maximum value, and then it's going to, everything else is going to be below that. So it's negative infinity to the y coordinate. Right, so let's try this one. We figured our vertex was -2, 6. So here is my x coordinate of my vertex. Here's my y coordinate of my vertex. This is a maximum, so it's opening down. So that means I have to go negative infinity to 6 and include 6. This one, just so you know, I do this a lot just to keep me on track. It has to open up, so this has to be a minimum. And this is a max. Okay? All right. Go ahead and watch the next video. This is where we pull it all together. Thanks for watching.